Hello everyone, I'm Ajay Kumar Jha, an assistant professor at North Dakota State University. So today I'm going to talk about our work titled JTestMigBench and JTestMigTax, a benchmark and taxonomy for unit test migration. So most of this work we performed while I was working at the University of Alberta with Sarah and Mohammed. So in this work, we first manually migrated JUnit tests, and then we analyzed those migrated tests to create a taxonomy for unit test migration. So in this work, we selected unit testing because it is a popular form of testing and it has several advantages. For example, it helps in detecting bugs earlier. However, writing effective tests manually is a difficult and time-consuming task. For example, developers have to identify all potential test inputs that could be used to exercise the target components thoroughly, which is a challenging task. So, to ease the process of writing tests manually from scratch, researchers have proposed various test recommendation techniques. And these techniques work basically on the same basic principle. So, they first find semantically similar method across applications, and then they check the availability of unit tests for those methods. And if they find one, then they recommend that test to developers. So researchers have found that these recommended tests are generally useful for developers in writing unit tests for the target system. For example, they can identify potential test inputs or use test inputs and expected outputs from these recommended tests to write test manually for the target system. However, researchers have also found that uh, developers cannot directly reuse these recommended tests in the target system. They have to modify these recommended tests. And sometimes this modification task can be a challenging task. For example, these recommended tests might have several method calls, and developers have to identify semantically similar method calls in the target system to replace them, which can be a challenging task. One way to mitigate this challenge is by developing automated tools and techniques that could transform these code elements in the recommended test and reuse these recommended tests directly in the target system. However, to do that, we have to first identify different types of code transformation needed to successfully transform these recommended tests. There are actually some test reuse techniques that perform a test code transformation, but these techniques perform limited types of code transformation. So in this work, our goal is to identify code transformation types necessary for reusing test cases from one application to another application. So for that, we first manually migrated JUnit tests and created a benchmark. So for that, we selected popular Java application used in the previous test recommendation and reuse studies. Then we developed a tool to find semantically similar method across these Java applications. This tool basically uses a word-to-back model and Levenshtein distance to find semantically similar methods. So using this tool, we extracted candidate similar method pairs. Then we validated these similar method pairs, and finally, we migrated unit tests for those similar method pairs to create this benchmark. So after creating this benchmark, we analyzed the migration-related code changes in these migrated tests to create a taxonomy for unit test migration. So in this work, we have two key contributions. First, a benchmark of manually migrated JUnit tests, which contains 186 manually validated semantically similar method pairs from 5 popular Java libraries. And more importantly, it contains 510 manually migrated JUnit tests for these method pairs. Our another key contribution is a taxonomy of migration-related code changes. So we created this taxonomy by analyzing migration-related code changes for these 510 successfully migrated tests. And we observed that to successfully migrate JUnit tests, we needed mainly three types of operations that are replace, changes, and removal. For example, we needed we needed replacement in 490 of these 510 successfully migrated tests. And these operations needed to be performed on various types of code elements. For example, we needed to replace method call, type, constructor, constructor with method call, and vice versa. We also needed to replace one method call with multiple method calls and vice versa. Also, we needed to change inputs and expected output values in the assertions. And finally, we needed to remove statements that are no longer needed. So our contributions have various implications for test migration techniques. First, test migration techniques need capabilities to find and replace semantically similar code elements, specifically types, constructors, and method calls. There are clone detection techniques that find semantically similar code elements, but these clone detection techniques are not accurate enough to be used for test migration purpose. So we need to improve the accuracy of these clone detection techniques. Also, we need to consider that one method call might be replaced with multiple method calls. So we need clone detection tools that are capable of handling this condition. Next, we need to adjust test oracles. So although we validated these similar method pairs, we found that they have some behavioral differences which we need to adjust while migrating the tests. And these adjustments could be syntactical, such as converting types, and semantical, changing inputs or expected outputs. For example, replacing exceptions with null values and vice versa. So there are test repair, test augmentation, and human in the loop techniques that could be used for this purpose. And finally, test migration techniques need capabilities to identify and remove irrelevant code elements that are no longer needed. So in this work overall, our goal was to identify general code transformation types for successfully migrating JUnit tests from one application to another application. In this direction, we mainly contributed a benchmark of 510 manually migrated JUnit tests and the taxonomy of migration-related code changes, which are available on our artifact page. This contribution can facilitate the advancement and development of unit test migration techniques. If you have any questions or comments, please feel free to contact us. Thank you for listening to the talk.